Our responsibility in directing AI. Even though AI mimics part of the human process of reasoning, adapting, and processing information, it is not at its core about replacing humans with machines. It is about harnessing the combined strengths of both humans and machines to process environments and solve complex problems from constantly changing factors and arising information. As we move more deeply away from the programmable era of computers, where we have explicitly told computers what to do, we move into a space where we give computers the tools to tell themselves what to do or how to do it, and to become better and better at it the more they learn. This is cognitive computing. It is the ability to mimic the human brain, to learn and to understand within a context that humans provide, and in this, be more of an assistant than a tool. It understands by sensing and interacting with data, reasons by generating hypotheses and recommendations, and learns what the lessons from masses of data are. It can take knowledge from different sources, bring it together, process and understand it without human involvement in every step. Some instances of machine intelligence are very specific to solving only certain problems or performing highly specific tasks. Part of this has to do with the data we have available to us, how that data is integrated, and our own capacity to help the machines verify their learning pathways and conclusions so that they may continue learning, even from their mistakes. Because data, and large amounts of it, are so important for any learning to take place, technology business giants such as Google, Apple, Facebook, Amazon, Microsoft, IBM, Baidu, and Alibaba are capitalizing on their data and are vying for the AI throne. Before digital technology and massive processing power existed, data existed in separate entities, not accessible or able to pass through one place, or virtually accessible. With digital technology, our ability to capture and store data in place and increases in processing power, which allow us to do this with massive amounts of data, we now have rapid access to all available structured and unstructured big data in one place physically or virtually. Big data refers to the large, diverse sets of information coming from multiple sources, arriving in multiple formats, and growing at ever-increasing rates. It encompasses the volume of information, the velocity or speed at which it is created and collected, and the variety or scope of the data points being covered. Big data often relies on application programming interface (API) integration between different applications, data from different places now able to exist in one place. Most applications or software components typically have an API, which is its computing interface that defines how other applications, systems, or software components can use its features, functionality, or data via a set of routines, functions, protocols, or procedures that specify the kinds of calls or requests that can be made, how to make them, the conventions to follow, and the data formats that should be used. Just think of all the different applications or programs you use daily. The ability for these to speak to each other not only makes your life easier on the surface, but allows data from these different places to communicate, share, and interact with each other in the background. We are indeed living in the API economy. The combinations of data and machine intelligence is also what powers AI as a service cloud-based solutions, frameworks, development environments, platforms, and applications. An AI as a service solution can, for example, provide the results of trained ML models in the form of inferences. ML algorithms rely on data, teaching, and knowing which results were correct in order to infer, in future, the conclusions based on more and more learning and more data. These inferences are the results we see when we are fed certain ads on Google or Facebook. The ML algorithm has inferred the content that would be of interest to us based on learning our behavior and interests. One of the key application areas of AI is data mining, which involves the process of discovering patterns in large data sets that makes data usable and less random. It looks for similarities, differences, relationships, and anomalies in the data to learn and reach conclusions. Data mining occurs in many layers, and as machines learn, the layers become deeper, sometimes finding patterns and discoveries that humans themselves may never find. To mine data, data often needs to be cleaned or prepared to deal with raw data that often exists either in duplicates, in incorrect data entries, or in contradictory data entries. Cleaning the data looks for these instances to try and remove or correct them so that the data can be used. Now that we have massive amounts of data in one place, information engineering deals with distribution, analysis, and the use of this information. In ML, the aim is to generate, understand, and use the data in a way that supports learning and inferences. Often data exists as a small sample of the population and thus is not a true reflection of the full picture. On top of this, because data is reliant on humans to add value to, clean, and mine, the data reflects what these humans deem important, the conclusions they are trying to find, or the value inherent to themselves. It is important to understand how easily bias occurs before training any ML model. As the potential applications for artificial intelligence is limitless, it will have a transformational impact on all industries. Understanding AI and its applications are vital to our lives, livelihoods, and the future we are creating with every present action or inaction. Artificial intelligence is not some distant future, nor is it something we can escape. It is here. For now, it is a black box for most people. But when a new technology is as pervasive and game-changing as machine learning, it is not wise to let it remain a black box. For how do we affect or direct what we do not know about or understand? How can we be a part of what we do not understand? More importantly, how can we control it if we do not understand it? We may think it necessary to control it, but just leave it up to the experts to understand it. But AI affects every part of life. It affects us directly, and we should have a say in the things that affect us directly. Because if what we do not understand, and therefore cannot steer or control, are so much a part of the world around us, and the tools we have as human beings to live, do business, to provide, to gain services, and have insights into things, processes, and each other, are we not intentionally removing ourselves from the core of the world as it is? It might not fit into our perception of the world as we know it. It might fit into our perception of the world as we wish it to be. It may not fit into what feels safe and known and comfortable, but it is still the reality we have, and by denying it, we are only excluding ourselves from being a true part of it. It is time for that to change. Some of the key reasons to prioritize learning about AI includes 1. Adapting to the speed of AI implementations. 2. The fact that every major technology company is prioritizing AI. 3. Companies that are first in deploying AI-driven solutions have competitive advantages over those that do not. 4. Most countries are implementing new laws and regulations regarding smart technology that will likely affect everyone. 5. To ensure ethical, responsible implementation of AI applications. 6. More benefits and opportunities are likely for productive members of society that work together with smart technologies. 7. Ensuring better collaboration between private and public sectors. 8. There is a shortage of knowledge workers such as data scientists, machine learning experts, and other technical professionals who can build AI solutions and services. 9. And the potential impacts on society. The sheer intelligence of the systems makes them feel less like technology and more like a natural human interaction where little effort or learning on our parts is required. This is contrary to the introduction of technology and digitization, where the onus was on us to learn, train, adjust, and come to terms with how to use completely new and sometimes complicated systems and processes. Even learning how to use a keyboard is an example of the effort humans had to put in to start using computers over traditional pen and paper. Still today, we are seeing low adoption rates in organizations that have tried to replace traditional ways of working with digital tools. While these tools are becoming simpler to use, without AI, there is still a large amount of learning, training, and adopting involved, which people sometimes feel is simply not worth the effort. Cognitive computing changes all of this. It makes the complexity of technology disappear, where using technology no longer feels like using technology. In fact, it will feel easy, natural, and intuitive for us to interact with smart devices. We are already seeing the beginnings of this with Google Assistant, Siri, Alexa, and Cortana. As we go deeper into untapping AI's capacity and power, intelligence will be so infused into systems and devices that may not even be aware that they are using technology. There will be no effort. We are on a steady path towards a hybrid future full of diversity where multiple AIs are interconnected with each other and even, perhaps one day, within us. Whilst we are years away from seeing the effects of human biology infused with AI, for example, in the form of chips, contact lenses, and so on, intelligent chairs, buildings, glasses, and cars are here and will soon be naturally interacting with each other and with us. We may think of algorithms in terms of AI only, but our brains use algorithms to see, hear, feel, learn, and understand. In fact, our brain uses the same algorithm to do all of this, and depending on the task, there are special parts of the brain that do the work and receive and send signals to either other parts of the brain or other parts of the body. However, if one part of the brain was damaged, for example, it is possible to direct those signals to another part of the brain, which would then become the new home of those signals and their subsequent tasks or results. This was demonstrated when a group of MIT students swapped around the eyes and the part of the brain responsible for sight, visual cortex, with the ears and the parts of the brain responsible for the hearing, auditory cortex. The result was that the ferret was able to learn how to see and hear again. This is because whilst firing different neurons in different directions and between different functions or parts of the body and their home in the brain, the same algorithm is used. The intelligence is the same, it is only the location that is different, and depending on the function or complexity requires a different number of neural connections to effectively work. In Yuval Harari's Homo Deus, he emphasizes that an algorithm is not a particular calculation, but the method followed when making the calculation. It is a methodical set of steps that can be used to make calculations, resolve problems, or reach decisions. Humans do this all the time. Each time we are faced with a decision, it is our own algorithms that decide how we will react. For example, if you see someone pushing in line, and that is met with a belief that pushing in lines is disrespectful, while you feel your purpose in life is to show people how to be more respectful, you're going to point out that that person pushed in line. Your own internal algorithm has led you to do this. Let us say the last time you politely showed someone how rude they were, you were punched in the face and left awfully embarrassed. This is now part of the data that your algorithm is processing. So even by deciding not to point this out, no matter how much you want to, you are still functioning in the framework of an algorithm. Your mind's algorithms are constantly at work. We use our internal algorithms when we're choosing the best way forward as well. We have all been in situations where we must decide which choice will lead us to our desired outcome. Sometimes this happens instantly and subconsciously, and sometimes we have time to weigh up the potential risks versus benefits. In both conscious and subconscious matters, we are analyzing the information before us, current data, past lessons, past data, personal beliefs and values, priorities for desired outcome, and things we would like to avoid, risks. We also do this knowing that some things have higher priority than others. Only the most mindful of you are aware that this process, or some like it, even occurs. You have most likely gone much of your life without even being aware that it exists. AI, machine learning, deep learning, and everything that results from these works in very much the same way. Only instead of inhabiting the brains, we are creating them. We are creating the algorithms that tell the systems what to value, what to avoid, what to favor. We are ensuring that they learn from new situations and incorporate their learnings into future decisions. We tell them what to look at, how to weigh what they are looking at, and how to know if they do not know the answer. The machine intelligence we are creating is our own intelligence. We are figuring out how our minds process data and make decisions so that we can guide machines to follow the same pathways and learn the same ways we do. Jeff Hawkins believes that we will not be able to create fully intelligent machines until we understand how the human brain works. This has been a question for psychologists, philosophers, biologists, neuroscientists, and neurosurgeons for many years. Everything the machines do is a result of humans. Everything they cannot do is a result of humans. Machine intelligence without human intelligence simply would not exist. It is important to remember that while these machines appear to be thinking for themselves, they are following a strict set of instructions and steps. Whatever they learn and however more precise or intelligent they become, they are still following the algorithm or the automated learning process created by humans. Our responsibility to direct AI towards favoring the good of life, all life, not just human life, is vital. To do this, it is important to understand our own algorithms and what makes them different. Each of our personalities and emotional responses, as Yuval Harari points out, is a result of our algorithms, however much more complex. While certain steps in our algorithms might be the same as our collective past data, evolutionary needs and developments, personal past data, history, current data, present situation, outcomes, values and goals, and weighting, priorities, differ. They will even differ in different situations. For example, our values or goals on a work project might differ from our values and goals for our careers, which will also differ from our values and goals in social situations. Making decisions in each of these situations will use a variety of different conscious and subconscious algorithms. If we have been taught to value privacy, autonomy, and self-actualization over harmony and collective good, a common value contrast between West and East, these will appear in the algorithms that make decisions. Similarly, if we grow up in a community, family, or greater society that sees black males as more dangerous or women as less capable, these too appear in our thought and decision-making pathways. The danger with machine intelligence is humans are creating it. The algorithms we create are therefore just as susceptible to the prejudices, values, knowledge, and biases that we have. The only difference is that the effects are on a much larger scale. Data bias is a huge problem for the world of machine intelligence, and the human element in creating AI is only part of why biases exist. There is also the fact that not everyone's views, needs, and priorities are reflected in the data that exists. Take social media for example. 2019 statistics show that Facebook users are at 2.4 billion, YouTube is at 1.9 billion, Instagram is at 1 billion, and Reddit and Twitter are both at 330 million. If we are to take the information, sentiments, and analysis we get from social media and use that to make decisions for the world, we are using data from not even half the world's population to direct further decisions and recommendations. It is ground for a disaster of biases. In later chapters, I will provide insights into how data bias can be avoided, checked, and accounted for. For now, the most important thing to note is that machines can only be as smart as we are. We need to stop seeing them as separate and start seeing them as the tools we create and use to achieve our own goals. I will conclude this chapter with some thoughts and sentiments from Demis Hassabis, a co-founder of Google DeepMind, that I also identify with and could materialize if we act with wisdom and take full responsibility in directing AI in ways that benefit as many people as possible. He believes that AI could usher in a new renaissance of discovery, acting as a multiplier for human ingenuity, opening up entirely new areas of inquiry and spurring humanity to realize its full potential, and that it is likely going to be the most important technology ever invented. Demis further states that by deepening our capacity to ask how and why, AI will advance the frontiers of knowledge and unlock whole new avenues of scientific discovery, improving the lives of billions of people, and that AI can help us build radically new and improved ways of life, and through our curiosity, the scientific method, and our use of AI to not only solve society's greatest challenges today, but to understand ourselves and make sense of the universe around us.